Hey guys, and welcome to EBPM. This is a video on a topic I feel like I should have done a long time ago, but I don't know why, I didn't really get into it, but I think I was inspired by a YouTube video I saw the other day called How to Get Started in Electronics, and I figured, alright, maybe I can make some videos here and help people out that are starting out with electronics. And it's really scary at first, I guess. There's a huge world of stuff. What helped me was the circuit theory, because circuit theory and math really helped me kind of focus my attention and to kind of comprehend what's going on. So one of the most important formulas is the Ohm's law equation. So I'm here in LTspice. What I'm gonna do is, oh yeah, by the way, I highly encourage you to get LTspice. I think this version is free, so just Google LTspice and download the software. And I would encourage you to get an actual circuit board and components and a multimeter. But for quick kind of stuff, a Spice program is just fine. So I'm going to click R to get my resistor, and then I'm going to, I can press Control R to flip it, but I'm just going to rotate it this way. Then I'm going to press F2, and I'm going to search volt, and usually it pops up right away, voltage. I'm gonna left click this onto the canvas or the board. I'm gonna press F3 to get my wiring tool, and I'm just gonna wire my simple little circuit so that I can demonstrate Ohm's law. Then I'm gonna press G, and the G button gives me the ground. I'm gonna press F3 and connect it to the ground node here. And let's right click on the V and choose a value of, let's say, 10 volts. I'm going to right click on the R here and choose 10 ohms. And because I know Ohm's law, I know there's going to be 1 ampere flowing in this loop right here. So let's press the run button. Let's do transient, and let's take 1 second of time. Press OK. Now I have this graph window above my schematic window. I can click on the node here with my left click, and I can see 10 volts here in green. I can then hover over the resistor. It changes into a ammeter, and left click. I'm gonna left click twice. So I'm gonna double click to override the voltage graph and just get the current graph. And here we go. You see 1 amp. Let me see if I can enlarge this window. So we have 1 ampere here flowing through the circuit for 1 second, basically, is what we got. That's kind of the most important formula in circuit theory. You're going to be using it a lot. It does have some limitations though, so I'll just go into that right now. So if I press left click on this node here with my voltmeter, and I hold and I move my cursor to the ground node, you see how my other probe turned black. And now if I release my mouse click, it'll give me the voltage across the resistor. So let me just add a resistor real quick here. I'm going to press F5 to get the scissor tools. I'm just going to cut up this a little bit to make room for my... Then I'm going to press F8 and then drag this in here. And I'm going to click F6 to use my copy tool. I'm going to left click and then get another resistor out there. I press F3 to wire this and complete the circuit. Now I'm going to choose 10 ohms here and 10 ohms here. So basically this is just 2 resistors of 10 ohms in series. So I double click on the, okay, let's rerun the simulation first. Alright, so on this node here we have 10 volts. Alright, makes sense. Now if I press on this node right here, between these two resistors, we have 5 volts. Let me just scale this to bottom 0. Half. So what you're seeing right now is how 2 resistors in series with the same value, the voltage at the point between them is half of this input voltage right here. So there's voltage being divided. So because they have the same value, it's the same. And let me show you. So you can't use Ohm's law anymore, because if you want to find what the current is, you have to account for the fact that there are now 2 resistors. So there are two ways to deal with this problem. One is you combine these two. So let me just copy this whole circuit. Press F6 for my copy tool. I highlight the circuit and I can just click it wherever I want. I press F5, I cut this away. Press F3 to complete the circuit. I press F8 and I move my resistor up a little bit, and I'll change this to 20. So these two circuits are kind of equivalent in the terms of the perceived resistance for the current going through from the voltage source. So adding two resistors together in series is quite simple. If I have two 10 ohm resistors, that's the equivalent of one 20 ohm resistor. Or if I have two 20 ohm resistors, that's going to be the equivalent. If you add those together, that's going to be 40. Let's do 60 and 100. So you can add those together into 160 ohm resistors. So if I use my ammeter on the left circuit, it gives me 500 milliamps. So that's what we were expecting. So if I do the same thing here on my ammeter on this circuit, okay, let me just, I press F5 and I remove the other transient analysis condition, and then I run again. Okay, and now I use my ammeter on the right circuit, and you see it's 500 milliamps. So in tackling a two resistor problem, what you can do is you can add them two together. Now you can use Ohm's law. So the trick behind Ohm's law is it only works on the component, the voltage across that particular component. So if I want to use Ohm's law in this specific example, what I need to do is I need to click on this node right here, drag my mouse until the probe becomes black, and then release. And if I do this twice, it'll override the graph, and that will be the only signal shown. So I just did it twice to be sure. And now we see that we have 5 volts across this resistor. And now we can use Ohm's law. So you can use Ohm's law when you have one component, and you can also use it when you have multiple components, but you need to use the voltage across that particular component. Another thing to keep in mind is that the current, when a component is in series like this, is that whatever current flows through R1 is the same current that's going to flow through R2. Because this circuit only, so from our first example we had 10 volts, 10 ohms, and now it's 10 ohms plus 10 ohms. So the current through this entire loop is just going to be 500 milliamps. So if you have components, resistors in series, then the current through those are always the same. So we got a 0.5, so we got 500 milliamps going through either of these. And that leads me to my second equation, Kirchhoff's voltage rule and current rule, and I'll get to those in the next video.